So I'm going to tell you something about reactive APIs, particularly using Spray. So just a show of hands, how many of you are using Scala and Akka? Oh, excellent, right? So it's the entire room, so that should be really, really easy. I have a couple of questions throughout, so don't be shy to shout out your answers. If you have any questions, just say so, and we'll see what we can do. The most exciting thing, of course, will be that we'll be writing code. So there'll be a few slides, but then we'll write some actual live code, and we'll construct a nice reactive application that does, I'll call it big data analytics of Twitter streams, but terms and conditions apply. If anyone, in the meantime, right, so we have 15 minutes to search for a suitable Twitter search term, something that will restore our faith in humanity, something really good. But anyway, we'll get there. So, okay, so an API, right, that's an easy thing. We can construct an HTTP API really, really trivially by having a function that takes an HTTP request and spits out an HTTP response. Well, that sounds really easy. Unfortunately, that's not quite what we would like. That sort of approach would suffer from being synchronous, blocking, so all of the reactive stuff that we've been hearing about for the last couple of days would fail in that approach. So we need something slightly different. Spray takes the reactive approach, and it says, okay, when we receive a message which represents the HTTP request that someone made, we can then reply at some point. We tell the sender our response, and that can be completely asynchronous. In fact, it is completely asynchronous. And given the bit of code that you see in front of you, that looks like a portion of an Akka actor. And in fact, that's what a Spray service is. It is an actor that receives, amongst others, HTTP requests, and then you can do whatever processing you need to do, and then reply with an HTTP response. But by that I mean you send a message back to the original sender, where the sender represents the connected client. So it's a completely different approach than just having a function that takes a request and returns an HTTP response. So here's how a real hello world service, we'll have to begin with that. So for that, every HTTP request that we receive, we're going to prepare an HTTP response, I suppose by setting the entity to be hello world and sending it to the sender. So still nothing completely difficult. What is quite cool, and I should mention that, is that because all Spray services are actors, we can test them really, really trivially. So if anyone's who's testing actors with TestKit? Most people, come on. You should be testing. If you're not, don't worry, the recording is just on me, so no one will ever know. In any case, so for our test actor, we can construct, say using specs2, a hello world spec, which extends TestKit, which is part of Akka, and then we mix in specification like to get the actual testing infrastructure, implicit sender, so that we can examine the response. We create a test actor ref to our hello world service, and then check that any request, for any request, our hello world service replies indeed with an HTTP response whose entity is hello world. So if all that works, we've written a successful test for our API. One thing to note here really is that we haven't started an HTTP server. This is just the API. So we're talking to the thing that sits behind an HTTP server, which you might find pretty useful if you're running any of these tests in parallel. But anyway, so how do we construct an HTTP server? Because without it, our API is, all very nice, but it doesn't do anything. Well, to do that, we're going to use the HTTP IO Akka extension. So by doing an IO of HTTP applied to an actor system, we get an actor ref to the low-level actor that represents the IO layer of the HTTP tier, or HTTP stack. And we bind our service to it. So in here, we've constructed the actor ref of the HTTP transport, which can parse HTTP requests, and we bind it by it, I mean the hello world service, to all local local addresses on port 8080. And then from that moment on, every request that we send is going to be routed as a message to the Hello World service. So that we'll receive a message, we'll react to it, and all will work really well. So, you know, let's now see, and I suppose the story will be pretty sad, because here's what's going to happen. If we ran this code, we would see a message that says something like bound the Hello World service to all local addresses on port 8080. So that's good, but if we now make an HTTP request, it will say that thing. First of all, warning, so that's not good in itself. And it will say configure registration, something really strange, and if we run it, say, in Chrome, we'll get that. And our problem is we just dealt with the HTTP request. We ignored the way in which Spray actually works. And here's what it does. Here's what we should have been doing. So we take the I/O of HTTP, the transport layer, and then we bind our Hello World service to it. Now, the thing that we quite happily ignored is the HTTP connection. You see, when a client connects, like a Chrome, or if you're using Telnet, when that connects, we get a message, our actor, our Hello World service, receives a message from Spray that says connected. It says the client has connected. And now Spray is expecting to receive a message that says, who's going to handle that connection? And we haven't been doing that at all. So if we wire that in, everything will work correctly. And so what we will invent on this slide here, when we receive a message, HTTP connected, we will reply to the sender. This is the Spray's networking layer. And we'll say self sender bang register self. And so in this pattern, we've invented a singleton handler. By singleton handler, I mean every client that connects is going to be handled by this service. If you ever wanted to spawn different services, so say for each connected client you would want to have different actors or different services, you could do that really, really easily. Now, a really good example of when you might want to do that is if you wanted to handle streaming HTTP requests. So a client connects, starts a stream for you, and you would create each individual actor for the chunks of the stream for all these different actors. And if you do that, you will see the different chunks of the stream as they arrive. So if you're doing, say, video processing, that might be a really good thing to do. Okay, so enough of slides, let's do a demo. So we'll build this Hello World app. So I happen to have one prepared, except what I have is, well, nothing of substance really. Can everyone see? Yeah, great. So this is a main app, thing that you recognize from, if you've been doing akka, create a new actor system, and then we wait for a read line before shutting down the actor system so we can see it doing something interesting. What we are missing completely is some sort of Hello World service, the Spray service that we would like to construct. So we can do just that. Hello World service. Actually, if I just write it here, in fact, which extends actor. And all we have to do is implement the receive function. So never mind the override, IntelliJ being too clever. So when you receive any HTTP request, then what we're going to reply with is HTTP response with entity set to HTTP entity that says hello with body hello world. So nothing too funky. Break it down so we can everyone see. So this would work really well if we construct our Hello World app properly. Here's actor system. Remember, we need to now construct the service by doing system actor off, props of Hello World service. So that's all jolly good. We need the I/O layer, I/O of HTTP by the system. And we'll bind this service to all local addresses on port 8080. I suppose a good question would be, why wouldn't we bind to port 80? It's because we'd have to run it as a super user. because we want to bind to ports above 1024. Console read line, just so it doesn't shut down before we can do anything interesting. So if I ran that, it should all work, right? Yes, great. So we have Chrome, new window, come on. Okay, right outside. There it is. All right, localhost 8080. Oh yeah, no data received. Any suggestions? And there's this thing. Right, so when we receive the actor connected, we're not registering self. Right, absolutely. So we'll register self, and all will be good. There we go. Excellent. So it all works as you expect. You can see the connected firing when you make connection. And say Chrome will keep the connection open for, I think, 60 seconds before closing it. If you were using Telnet, you would receive another message here saying connection closed. So you might decide to do something interesting depending on when clients appear and disappear. Okay, so that was Hello World. And you know, it was good. Unfortunately, you couldn't really write complex API by handling all these HTTP requests coming in. So it was trivial to say any request will reply back with hello world. Well, that's all good. What if you wanted to match on, I don't know, paths? What if you wanted to match on HTTP methods, parameters, headers, cookies, anything? It would become really, really complicated. And so Spray actually provides a convenient DSL that you can construct, that you can use to construct routes. So routes are sort of like matches that you can throw an HTTP request to, and it would run through all the different fallback options, and when they match, you know, your code would execute. So we'll see how that actually looks like. You can construct the routes using the DSL, and then turn the route. This is the important stuff. You can turn the route into a correct implementation of the actor receive method. So all the work that we've done by handling the HTTP requests coming in and the HTTP connected, we could turn a route that we construct with a DSL into that very same receive implementation. And what's even better is we can have similar DSL to unit test our routes. So rather than construct using testkit, sending an HTTP request message, we can have a convenient DSL. All right, here's what it looks like. So slightly more strict hello world. So by slightly more strict, I mean we restrict it to HTTP method get. So this is a route that when it receives an HTTP get request, any request, you know, any path, any query parameters, any cookies, none of that matters. We will complete it by returning a constant at this point, hello world. We'll just say every request like that, spit out hello world to the client. And that's all we have to type. So that's really, really convenient. All these directives, like get and complete and all the others that we'll see, are defined in the trait directives. So you write a trait and then you extend or mix in directives, which gives you access to all the Spray's different directives. And we'll explore some of them, of course, full details, all online. So this is how we can turn the route into a correct implementation of the receive method. So whereas where we had the hello world service that actually had to handle the connected and HTTP requests method, we can extend HTTP service actor, which is one of Spray classes, and the implementation of the receive function is simply run route. So we can turn route that we've constructed earlier into a correct implementation of the receive method. So far so good. The testing gets a lot better. So rather than sending an HTTP request, we can just construct a get HTTP request with root, no path. We will send it to the demo root that we've constructed just a moment earlier, and we will check that the response as string is equal to hello world. So if you compare the previous testing approach, this is a lot more pleasant. And yet again, this is without the HTTP server. So you can run all these tests in parallel. You can unit test your APIs. So that's really, really powerful. Okay, so let's try it out, right? This should be really easy. So instead of worrying about our hello world service, let's do something slightly more interesting and construct our demo root. So we'll extend directives and call it demo root. I type root. Again, you can probably leave that out for Scala to figure out, but since we're constructing a public member, let's give it the type annotation properly. So on any get, we'll complete with the constant hello world. Okay, great. So that's a valid root, but it doesn't really do anything on its own. We need to have this HTTP server, I suppose. So the actor, us, call it main service, which takes a root and extends HTTP actor, service actor, and the receive is now run root of that root. Okay, great. Just for convenience, I suppose we'll create a main service companion object with the root. So this is how I find it very useful to combine all the roots. So we'll invent more and more of these traits, and we'll combine the roots together to build an API. But each trait, like the demo root that we've seen here, is completely self-contained. It handles one aspect of your application. So I find it useful when you have, say, processing of orders, processing of customers, whatever you like, to have it in its own trait. And then you can combine multiple of these traits, mix them into, say, a companion object, just like I've done here, and construct one final root that represents your entire API. So if you want to unit test individual tiny sort of subsets of your API, you look at the traits. If you then want to test your entire application just to make sure that everything is still holding together, you can use this final root that we will combine by combining these smaller roots together. We'll see exactly how we go about that. The rest of it is, well, precisely the same, right? Service we'll get by creating system actor off, props, this time though of new main service, because we need to give it main service root, the companion objects root. So breaking it down like that. We couldn't just say props of square bracket because we have a constructor param now. And then the rest of it is really just the I/O layer, and we'll bind the service to all local addresses on port 8080. So if all of this worked as I expected, then running this should produce exactly the same result, right? It will still say hello world. Okay, where is the second window of Chrome? Come on. It does keep hiding. No, there we go. Localhost 80. Hello world. Exactly what you expected. But the syntax is now a lot more pleasant. We were able to split out the actual root that we're constructing, the API, the thing that reads well, the syntax sugar or syntactical noise-free version of the API, from the underlying mechanism of how we get this API bound to some host, some HTTP host. Okay, so far so good, but come on, demo hello world is getting pretty boring. Let's do something a bit more exciting. We can match on different things. So you've seen matching on HTTP method. Can match on paths, so including the, back in the days, fancy variables. We can match on path segments, query parameters. I've picked another which is an HTTP header. So if you wanted to find out what the user agent was, you'd match on header value by name, you can match on cookies, and there's a whole host of other matches, other directives that you can have a look at on spray.io. I'm not going to list them all. But the important one, though, is that we will combine the different directives using this tilde operator, if you like, a function. So we can concatenate smaller roots together to make a bigger root. And that's going to be really crucial in how we construct the API. So let's take a look at a few. We'll just match on URLs as an example. So to pick on this, let's construct a URL matching. Get rid of this. Direct root, which also extends directives, so we get the directives from Spray. Pick a name for the root, say URL matching root as. So what are we going to do? Say we want to, on an HTTP GET, if the path is customer followed by an int number. Now, this is really quite crucial. This is really, really useful. What I've done is, here, I want to say that a URL that begins with customer followed by some integer. And what I would like to do is now extract this integer. In the rest of my matches, this now needs to be completed with a function that takes an int number, which is what this directive exports, because it is a number matcher of type int. So this now needs to take as its parameter a function that takes a number and completes the request, just like we've seen before. So whereas in the previous world we've seen a get followed by immediately complete with hello world, we now have to provide a function that takes an ID, because we said int number here, and will complete by saying customer ID $ID, like so. So this is a completely valid Spray DSL request. We've extracted the int number. This is actually an int. This is all strongly typed because we said directive is an int number. This is indeed an int. We can do a very similar thing by taking a query parameter. And what we're going to do is combine it with the tilde operator. So Spray is going to say, okay, I'm going to first try this. If I get a request that matches these conditions, if you like, I'm going to execute what follows. If it doesn't, I'm going to try this other thing that I'm going to write right now. So if it is a path with just customer, but it is with a query parameter of type ID, and we'll do it as int. And this is the customer ID, and we'll complete, come on, with the same, say with the same thing, says customer Q ID, just so we can tell the difference. $ID. Okay. Just a quick question before I go on. Does anyone know what this is in Scala? It's a symbol, right? Absolutely. So we can name a symbol for the parameter, like ID, that's quite useful. So you might actually stick it into some other trait or an object, and you say, for every ID in my system, this is the symbol I want to use. We'll turn it into an int, and so again, this strongly typed parameter ID will be checked to be an ID. We can do a similar thing, so on a different path, say, let's say we do colors and RGB. Oh yes, misspelled. But anyway, this is spelled properly for me. So let's have 3 parameters this time, RGB. So this will now receive a tuple containing 3 elements, R as int, G as int, and finally B as int. The method that I have to now provide is a thing that takes the RGB tuple and completes. So we can complete by saying, ooh, we can even do HTML, right? So we can do this sort of business. This is the Scala's XML matching, so let's do 3 paragraphs. I'm not actually suggesting that you do that. This is a terrible idea, but you could. These are the different versions of the complete handler that you can use. R, G, and finally B. Okay, so this is all looking good. We've combined the different parameters, combined the different paths. So let's make sure that we can use it and give it a try. So in main service, let's for now get rid of the demo root because that would catch any GET request. So if I run this now, we should see everything working as we expect. So what did we have? Localhost 8080, customer 50. Okay, so that worked exactly as we expect. Validated, of course, so this has to be an int number. So if you overflow, that's not a valid request, which is quite useful. It doesn't match. There is no other route that can match this request. This doesn't match, so none of the usual things match. Query parameters work as you would expect. No problem. Again, same validation rules apply, except you get a better message. This is not a 32-bit integer. Great. What about the colors? It's the same business, right? I'm sure you can imagine, oh, I don't know. And B is, no, I have that. RGB is 34. There you go. But pretty HTML, 3 paragraphs. Before we go on, I suppose the main problem with this code is I can type things like that. And that's sort of not a good color. So what do we do? Well, we would like to do a little bit of validation. So how are we going to do about it? Well, it is interesting to realize that Spray under the hood, these parameter matchers use a library called Shapeless under the hood. Has anyone tried? Anyone had a look? One? No one else braved? Okay, anyway, so it turns out that there is an easy way to go from tuples to case classes, back and forward. So we're going to take advantage of that, and we will invent a case class, right here, color, with R of int, G of int, and B of int, and we will require all these 3 to be between 0 and 255. R is greater than or equal 0 and equal 255. And I suppose some intelligent message, like R valid color, range, something like that. I'm sure you can invent a better one. So we'll do these for G and B's. Okay. And B, G. Now, here's the cool thing. So what we're going to do, these are all good, but we will treat this whole thing as color. And now the rest of it, this is now doesn't want 3 things, it wants 1 instance of color. So far so good, but I'd have to change that. Now I would have to say color.r, color.g, color.b, or I could, because I'm lazy and I would wear out my keyboard, just do that. Import the R, G, and B members. And so it's red, that's IntelliJ being stupid. We're far more clever than that, and we can see it run. So let's see. Excellent. So our validation is there, and if it is successful, we get the same results. So yay, great. Good question. Yes? Let's find out. So if we do it on a slightly better result, on a get, you get back 400. There is no such route. It's not found. It's an invalid request. All right. So, seeing that, I can show you a few more, but I'm going to cheat now because this is getting slightly boring. We're typing a lot of stuff and not seeing anything too exciting. The good news is you can do the same thing in your project. So let's move to URL matches, like so. So suppose I've typed all of this stuff in. We can match on URLs, as we've seen before. We can also match on cookies if we liked. We can match on header parameters. So if we wanted to, for some reason, to find out what the user agent is who's making the request, we could match an HTTP header like so. So we'd have a browser on a GET request. We'd grab the user agent value of the header. And now this is, again, an important thing. We need to supply a function that takes a string and returns a function that takes a request context to unit. We'll get to the details of it in just a moment, and we'll see how all of that fits in. The important thing here is how we've combined the roots together. So I've mixed in our main service, I've mixed in the URL matching root, and the header matching root, and the cookies matching root, and I've combined their smaller roots, these individual small chunks of the API, into a final entire API by combining these smaller ones together with a tilde, just like we've done before. So that's all really nice. Let's do something, this real thing. But before we jump into that, let's take a look at completing these requests. So what we've seen so far is a situation where we've completed with either an immediate constant, if you like, the hello world string, or we've completed by trivial replacement of a string. So customer ID and HTML where we've changed the R, G, and B. What's actually happening behind the scenes is that Spray expects us to complete the route by providing a function that takes the request context and returns unit. Because it needs to remain asynchronous. We couldn't say, take an HTTP request and return HTTP response. That would break. We need a request context that includes the HTTP request, but it also contains a responder, a thing that I can send the responses back to. And so complete does that, and it hides all this complexity away from us. But looking at that route, so suppose we want to build our tweet analyzer, and we'll get to that in just a moment, what would we have to say in place of the 3 question marks? So I guess the first thing to think about is the path directive wants us to do something, and then we want to complete the request by providing a function that takes a request context and returns unit. So any suggestions for the question marks? Yeah, right. So it would need to be a function from string to a function of request context to unit. So we can do just that really easily. So that is perfectly, the send tweet analysis, the shape of it, matches that perfectly. So as we uncurry the bits of the code, so this matches what path/segment requires. It's a function that takes a string. And now we need to complete this entire request by providing, and we don't want to use the complete function just yet because we're going to do something really fancy. We need to provide now a function that takes a request context and returns unit. And that's that. So that all fits together. Okay, good. So a real app, the thing that we're going to build. We have 20 minutes to do it. So let's do that. So what I'll show you is how to actually combine an actor system under the hood with a real actor that does something interesting, and an actor that actually makes a connection to the streaming Twitter API as well. And we'll use Spray client to do it. So what I've skimmed over is that in Spray we have both the server and the client components. So we can build streaming reactive HTTP clients, non-blocking, as well as servers. And we'll take a look at how we might want to do that. So, given a Twitter search term, we will count positive and negative tweets. I've actually downloaded big CSV files with good words and bad words for the English language. So we're just going to do a trivial thing and say, if a good word appears in the tweet, we'll call it good. If a bad word appears in the tweet, we'll call it bad. We'll split it by languages, and we'll split it by locations. And we'll do some fancy graphs if we have time. But anyway, let's see. All right, this is what it's going to look like. So I've given it away a little bit. D3.js, if anyone's afraid of JavaScript, no need. It's all provided. and it will all be animated and everything, so ready for management anytime. Okay, great. So here's what we're going to build. Our AngularJS app is going to make a post to /tweets/query. So this will be the query that we send to Twitter. But what it's going to receive is a chunked HTTP response. It's not going to be just one response. It will be a chunked connection. And it's going to receive these bits, these chunks, which will be the analyzed data, as we receive tweets from Twitter. So there'll be no polling in this entire thing. It will be all entirely reactive. So as Twitter API sends us message chunks, we will turn them into tweets, do our analysis, and then send to whoever is connected to us, which will happen to be the AngularJS app. So really easy. 3 things we'll need. Sentiment analysis, I happen to have written already. We're not going to sort of bother with that. So that's all ready in the code. We're going to have to write our tweet analysis route and tweet redirector. So that's all there is to it, really. So let's take a look at it. So we'll begin with our tweet reader. So here it is. I happen to have. So what we're going to do, what are we going to do? Well, let's start with an actor. Just a class. Tweet reader actor, which extends actor. So that would be it, right? So when we receive query of type string, so this is the thing that we want to send to Twitter. We're going to go off and contact the Twitter API, and we will establish the connection, and then Twitter will send us HTTP message chunks. So it's going to send us bits of the HTTP stream. So message chunk. So Twitter is going to send us this sort of entities. I don't even care about the extensions. So this is where we've received one tweet from Twitter in a reactive way. We get told. We don't poll. Twitter tells us, or rather, the HTTP connection to the Twitter API is a streaming connection, and as we receive the chunks, we'll see it in our actor. We will do the analysis, and we'll send a message to some receiver, not the sender, right? So if I did sender bang here, the sender here is the connection to the Twitter API. So that we really don't want that. So we need a receiver, if you like. So that's a thing that we will send the analyzed things to. I'll say, let's send a unit for now, just for good measure, just to get it to compile. So what do we need to do? Well, has anyone tried Twitter API? In Java, okay. The unpleasant business is that we have to do OAuth authenticate every request. So let's take a sidestep and just invent a trait, Twitter authentication. And that's going to contain a method, nice, which is going to take an HTTP request and give me a new HTTP request that's now authorized. So power of abstraction, right? I haven't actually implemented anything, but what I'm going to say is that instances of the tweet reader actor will need to mix an appropriate authentication in. So we will have to instantiate them with the right implementation of Twitter authentication. All good. I've only done that to actually save time, because what we're going to have to do is construct the client I/O connection. So again, I/O HTTP applied to context system. So this is the same actorref to the HTTP I/O extension that we've done for the server. We're going to use it for the client here. We will grab our sentiment analysis that I have earlier. And this is the cool stuff, right? So we have all the infrastructure set up. So when we receive a query, we need to construct an HTTP request, called the post body, the form that we're sending to Twitter. It will be an HTTP entity. It needs a content type, and it needs these silly media types. And we'll be sending application X, come on. It's the www form encoded. Can anyone see that? That's the one, URL encoded form. And the body will be track. So this is the actual post that we have to make. It will be an HTTP form of type form www URL encoded, and the body is simply track and the query, the expression that we want to track. So that's the entity that goes to Twitter. We need to now construct a request by doing an HTTP request with this given entity, so which will be an HTTP method. We'll be doing a post to the Twitter API. I'll cheat here and take, suppose we also get a URI that's given to us. That's where it goes. So HTTP method post to the given URI with the given entity. Now, how about this authentication, right? So now that we've mixed in Twitter authentication, I can just have it authorized. Like that. So I look at the shapes of the things. Authorize is a function that returns a function that takes an HTTP request and returns another HTTP request. Well, I can do the same thing, right? I have an HTTP request here, and I need to turn it into an authorized HTTP request. So the DSL that Spray offers is this arrow. So take that and turn it, pass it on to authorize. Okay, great. And now to actually do the business. So send to the IO layer, we're going to be sending it, and the responses will be received by us here. So received by self, and we're going to send the request. That's all there is to it. I mean, it needs a little bit of reading and writing, rather reading of the documentation to figure out how to do it. But the crucial thing is, there is this notion, this is not a request response. We make a request, sure enough, but then we'll be saying the responses that we get as a result of making that request to whoever's listening, we would like to receive the bits of the responses. And so that gives us the opportunity to here deal with each individual message chunks. So all that we have to do is to turn this entity into an instance of a tweet, right? Because entity, that's just bytes. So if I look at it, it has a body. I can do an S string as an example. That will give me the JSON that represents the tweet. I don't really want to be dealing with JSONs at this level. I'd like my objects. So I need to unmarshal them. So I've already actually written a tweet unmarshaler that I can mix in as well. So all that we have to do now, really, is to unmarshal it. Tweet unmarshaler, apply it to the entity, and we'll match it. So the tweet unmarshal would either give us a left of some error message. So this is where the JSON that we received, or rather the entity that we've received, cannot be turned into a tweet. We should probably do something slightly more intelligent than nothing, but for the demo app, this will suffice. If it is, though, the right one, so if it is a right, and this is the tweet, and I have the tweet, all I want to do now is apply it to our sentiment analysis on tweet, given that tweet, and the response of that is going to go to the receiver, just like I've done below. So this is the whole business. So this is it. I mean, it really is 10 lines of code, 15 lines of code to do a streaming connection to an HTTP stream, unmarshal the tweets, do some sentiment analysis if we like, and send it to some receiver. So this sum receiver is going to be our tweet analysis root. So that will be the crucial thing. But before I do that, I have to do one thing. I might have to, actually no, I won't tell you, I won't give you my passwords. What I might do is implement the OAuth Twitter authentication. What I happen to have is a file on my computer whose 4 lines represent the API keys and the OAuth tokens. So that's not on GitHub, unfortunately, but go ahead and create your own, and you'll see exactly how that works. The important thing, I'll get to that. Like so. So I have in my home directory, .twitter and Philly ETE 2014. So if you create that file as well, apply for a Twitter token, create a token for your app, and this will work without any problems. Okay, so that's all really good. All that we have to do is to construct the root. So we've seen the Spray client. This is a thing that allows us to connect to the Twitter API and receive this chunked HTTP post, unmarshal it, deal with the tweets. What's missing is the server side of it, I suppose. So our tweet analysis root, which extends directives. Okay, so it's just like the slide that you've seen, really. Tweet analysis root of type root. So when we receive a post on path, let's say tweets, followed by a path segment, come on, we want to apply to it our send tweet analysis function, right? Tweet send tweet analysis is a function that takes a string because of the segment, and it returns a function, so we can do currying, that takes a request context and returns a unit. And so in here, our job will be to send responses to the context's receiver. Responder. So if we send responses here, that's what the client is going to see. So the connected client. So that really shouldn't be too hard, right? This is the magic stuff. So what are we going to do? Well, in here, we need to now construct our tweet, this actor that we've constructed, the Twitter reader actor. So that's going to be slightly awkward, right? Because how does one create an actor? What do you need to create an actor? Well, you need some sort of actor system or an actor ref factory. And we don't have one here. So here's what we could do. Actor ref factory. So we'll turn tweet analysis root from a value or a variable into a function that needs an actor ref factory. And in here, we'll do the same thing. Like so. So the main question, I suppose, that you could have is, why implicit? Can anyone think of a reason why I made this last parameter implicit? Right, so I don't have to type it in. That's good. But if it weren't implicit, then the shape of this function wouldn't match. So by making it implicit, the choices I have is either make it a first parameter and then apply it here, or make it implicit and then just sort of wash our hands off the whole business. Now that we have Scala, we have to make it implicit, right? Implicit is the whole business of Scala. So in here, we can now easily create actor off. We can make some interesting actors. So this is the actor that's going to make a request to our Twitter API, our Twitter reader actor, and it's going to receive the responses, turn them into JSONs, and send them back to the client. Nothing could be easier. Well, it's going to be a lot of typing. But what can we do? We have to do programming, unfortunately. Tweet analysis. Let's call it streaming actor. Okay, so that receives the query of type string. that's given to us. Good. Responder, actor ref. The whole business is an actor. So let's see how that's going. I'll leave that for now. I'll leave the receive method just like that. So here's what we're going to do. When we receive this request, I'm going to make an instance of this props of new tweet analysis streaming actor. This is the query that's being given to us. So that's the remainder of the segment. And the receiver, the thing that is going to receive the responses to be sent to whoever's listening on the other end of the connection is context's responder. So, like so. So all that we have to do really to complete is to give an implementation of the receive method. So what are we going to do? Well, we need to construct in here. First thing we do is going to construct our reader actor as context actor of. This is a child actor. This will be a props of new Twitter reader actor. Come on. Tweet reader. That's the one. Contain tweet reader actor Twitter URI. The receiver. This is the interesting thing. That will be self. We want to receive the analysis results. So the Twitter actor is going to do some processing, contact Twitter API, and the responses it sends, we want to see here, because we need to turn our analyzed results into responses that the clients can deal with. So some sort of JSONs, perhaps. Okay, that's nearly it, except we need to mix in a OAuth Twitter authentication as we promised. Brackets are closed, so that's all good. And we will construct a response start. So this is when the clients connect. This is the first thing that they will receive. HTTP response of with entity as HTTP entity with application JSON, I suppose we should say. Son, and the body is just an empty thing. Do I type this in properly? Probably not. Let's import content types. So we get our application JSON. So this is the first thing that the client is going to receive. And what we're going to say, this is the crucial bit, right? So the responder, this is an actor ref pointing to the HTTP client that's connected to us. We're going to send it a chunked message start, chunked response start even. We're sending the responder, yeah, that's the one, chunked response start. This is the response start entity that we're sending it. But what we will want from the client is to receive an acknowledgement. So call it start. Because what we don't want to do is to start flooding it with responses before it even has a chance to say, yes, okay, I've received the first bit of your response. And so in our receive function, now this is the interesting bit. So when we receive our start symbol, so this indicates that the client has received our first chunked response start, and we'll be able to start pushing the rest of the response to it. So what are we going to do? Well, we'll send a message to our Twitter reader. So that says, okay, we're now good to go. You, Twitter reader, go ahead and contact the Twitter API. Let's start reading the tweets. And it is going to send us this horrible thing. Analyze, I'll call it, which will be a map of string to a map of string to int. I'm sure I could have picked a better data structure, but just amuse me for now. All that we have to do is turn that into a JSON, and what we're going to do is turn that into JSON. So suppose we've done that, so we have a body, which is an HTTP body, and we'll say a responder, bang, body. Responder, there we go, it helps to type it properly. So this will be our message chunk that goes to the client. That's all there is required, really. I don't want to bore you with the typing, so I'm going to cheat a little bit. Like so, suppose I've typed in all that stuff, specifically to turn the analyzed map of string to a map of string of int into a JS object. But the pattern still remains. Start the connection, and then I start sending small chunks. So, we're nearly done. This is nearly the whole business. What remains, if you remember in our main service, we still have the main route that combines all the previous routes that we've combined. So all that we have to do now is to add to it our tweet analysis route. So we'll combine tweet analysis route. But, so this one's the actor factory. Well, nothing could be simple, right? Root taking an arf. Factory, like so. Great. So it all works. With a slight massaging of this, we're done. So this all works as you would expect. So, you know, fingers crossed. Let's see. Run it. Yes, erased, we know, unfortunately. You know what? I'm going to stop the previous app that I had running. Otherwise, we wouldn't see any meaningful responses. Let's do this properly. Okay, so far so good. So let's do it the hard way, right? Telnet. On localhost 8080, that's where we've bound. So what are we doing? A post to tweets. Any suggestions for the actual query string? Grumpy cat. Okay, I'll do UK. I've practiced UK, so that's kind of good. When we're doing HTTP 1.1, our host is localhost, and we'll complete the HTTP request by doing one more line. Right, so that's chunk message start, and these are the values. So this is exactly as we receive it from Twitter. It's exactly what you expect, but completely non-blocking. There is no polling in any of this code. Now, you might be saying, Telnet, this is the best invention ever, right? But users don't like that kind of thing. They like this Angular JS business and pretty web pages. So let's stop all of this. Oh no, sorry, wrong button. So this is running again. I happen to have, oh what? They're finished. Impossible. I happen to have a bookmark here. So it's the same business. This is just a trivial HTTP client XML HTTP request with an Angular JS app with a little directive for D3.js. And so without any more yakking, let's see. So this is the first response. Here are the values as we've seen them. This looks pretty, right? It's just moving. I could have done bar charts, but then again, I can't really do JavaScript. So this is the best you get. Nevertheless, this is actually it with 0 I/O time spent waiting. So that's all there is to it. All the code is on GitHub. What you do get, there's a blog post as well. What you do get with the code is roles. So you run SBT, and then you can follow everything that I've done here. So you can go next, 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 and try to build up the entire application yourself. If you wanted to practice. So that's all there is really to it. One final thing. Suppose you wanted to know how we're doing. So I'll stop this, do an SBT run. What I have done in this case is wired in a little bit of a monitoring infrastructure. So this is AK23. Let's run the main app again. Refresh this. What you do get is a little bit of, this is a stats-d monitor, so we can find out what's going on. except it would probably need a bigger resolution. Ah, there we go. Okay, all right, goody. So, okay, let's start tweet streaming. So these are the results. We'll let it run for a bit, exactly as you expected, and we can find out what the app is going to do. So in just a moment, we'll see the actual requests coming in. So we'll see the number of tweets coming in, we'll see the number of messages that we're sending out, and just for good measure, how much time we're spending in I/O waiting on the CPU. So give it a few seconds. While it does that, any questions? Ah, right. That's coming up on the last slide. Yes. Hang on. 1 second.
What if I want to put some kind of authentication?
Right. So one of the directives that you do get with Spray are authentication directives. So you have basic authentication, which is the trivial stuff. You provide a username, password, realm, or you can implement your own where the response, you write an authentication directive that wants a function that takes an HTTP request context and returns a future of authentication. So this is where you can wire in your own actor that does the authentication and then either replies back with accepted or rejected. Nice and easy. Anything else? Anyone else? This isn't really happening. There's one more question.
Do you have conventions or guidelines for if you have a large number of endpoints?
Right. So this is what I usually do in my applications, particularly the big ones, is to split the endpoints into smaller trays, just like I've done here. So divide the API into smaller chunks that you can actually, if you even wanted to deploy individually. So the idea is that it should be possible to construct smaller public static void mains, if you like, containing subsets of your APIs. And if you wanted to, you would then construct one big fat API by, as you can see here, combining the different routes that you need. Again, just like I've done here. That's a pattern that proved to be very useful to me, even in a large application with a couple of hundreds of endpoints. Hey, anyone else? Okay, well, thanks very much. Slides. Thank you.